In this problem, we are asked to predict how much force a strut with a modified diameter might be able to handle. And the first question we might ask ourselves is, what is a strut? Well, a strut is really just a bar that supports a tensile or compressive axial load. So we can say a bar, that's a little bit better, A. And it might look something like a cylinder with forces applied at each end. And in our case, our bar has a circular cross-section, it's a cylinder, but a bar could be something with a rectangular cross-section, hexagonal cross-section, or something else. Now, using the notes from our meeting in session 1, we have some type of understanding of what happens if we increase the diameter. And we know that it does increase. In fact, we didn't even have to go to class to know that. If you make a leg on a table larger in diameter, it's going to support more force. So yes, this statement is true. Now, what is the equation that we might be able to use? And again, this is not too difficult. We're getting started in the class, but we can write out the increase in the amount of supportable force that we have as, well, increasing with the ratio of the, as long as it increases as long as the diameter increases. So we have that the new force that we can support is going to be equal to the old force times the area, the new area over the area that was previously there. Okay, so moving forward, we write out equations for the area, and we know that pi over 4 is going to cancel. Pi over 4 d squared. And we can write that we have 235 kip over this ratio of the squares of the diameters, and that comes out to be 940 kip. Now, this may seem pretty straightforward, and in fact, it is. Nonetheless, I would like to take this opportunity to show you how you might go about using Python or Colab, Google Colab, to be able to run this calculation. So if you go into Google Drive, or you could go to Colab directly if you wanted, and then create a new script file. But here we can create this Google Colab file. And the first thing that we do is we import appropriate libraries. So it has some suggestions here. And I think these are somewhat related to things that I've worked on in the past. But the first one is what we're going to use. We're going to use the NumPy library. Oh, I didn't want all those. Okay, so I can do that. And then we can hit run, and it's going to go ahead and bring that in. I like to create another cell so that it doesn't run that import operation every time, but you could do something else. And we're going to go ahead and put the old force as our first variable. And this is the 235 kips that we had previously. So I'm going to say 235 times 1e to the 3. That's going to give me pounds. And we're going to be operating in pounds, so it's not a bad idea to put a hashtag there, which is just really a comment out thing, to let us know that this is a pound of force. Now, the new supportable force, okay, is going to be given by this old supportable force, okay, times a ratio of these squares of the diameters. Okay, so to do this, there could be I could do this a couple ways, but I guess I'll be a little bit messy. But I'm going to do, it's 6 divided by 3. Okay, and unlike MATLAB, it's not a caret symbol, but it's 2 asterisks. Okay, and it comes out like this. Okay, and if I look at things, I've tried to be somewhat careful with the dimensions. You have inches over inches, okay, and they cancel out. This is going to have the old unit. So again, this is going to be units of pounds of force. Okay, so I can go ahead and run this, and you're like, wait, nothing. I don't see anything. Well, as you saw, it was wanting us to give a print command in order for NumPy or for Python to spit out the answer. So with print, sometimes you want to make it look a little nice. And so what you can do is you can say, okay, I am going to tell you in English, well, maybe in somewhat English, F supportable new is, okay, and I do space, and then I do a comma, and then I can do, I don't necessarily want like a ton of decimal points, so I can do mp.round, and and then I put in the F supportable new, and it's even pretty smart in terms of knowing what I might want. And then the next thing is a comma, and you can put the number of decimal points. So if I just do 1 decimal point, then that'll just give me, well, if I put a 1 there, that'll give me 1. And then I can go back to typing my characters or my text. So, and we're just going to have units of kip. All right. So now I can hit Control Enter to run it, or I can come over here like this, okay, and it does it like that. All right. Oh, but that's not the right units. That's not in kip. All right. So what did I do? Well, this would really be in pounds force. Okay. So that's, now it says in pounds force. But what if I do want it in kip? Because that's what I had. Well, another way to do this is to divide by 1,000. Right? That will give me the conversion. So look at that. It even has some clues from, wow, that's a little bit scary that it knows a little bit about the types of things I've done in the past. So this is not kilonewtons, but it's going to be in kip. And you see that we took this load and we divided by 1,000, 1E3, just like that. Okay? And so now it looks a little more like what we would expect. All right? And yes, we did in fact write in our example that we had 940 kips of supportable load. Thank you.